so the fifth root of x, I'm going to switch over to Desmo so you can get an idea of what that looks like. So here's the fifth root of x I claim. It's like a snake on its side. And the reason this is the fifth root, if you remember from your previous math classes, if the index is 5, then that would be the denominator of your fractional exponent, your rational exponent. So this is the fifth root, or x to the 1/5. And you can tell from that picture what the intercept is, can't you? There's only one. Who's my intercept?
Origin.
The origin, right? It might look like a straight line, but if I zoomed in, you'd see that this is curving in. It's not a straight line, because then it wouldn't be a function. Okay? So it's curving in, then curving out. What kind of symmetry does it look like we have just in the picture? Origin, well done. Yeah, that's definitely origin, quadrant 1 to quadrant 3. Okay, so now that we know what's going on, we know the intercept is the origin, and we know it's origin symmetry, let's prove it. So again, we're asked to find the x-intercept, the y-intercept, and test for symmetry. So symmetry, we're looking for y-axis symmetry, we're looking for origin symmetry, and we're looking for x-axis symmetry. Okay. For intercepts, we know it's going to be the origin, but let's see how we would have gotten that without the picture. For x-intercepts, that's where we let y equal 0, right? So 0 should equal the fifth root of x. But how do we solve an equation that has a radical? Do you remember how to do that? How do you get rid of this fifth root of x? You put it in parentheses and raise it to the fifth 5. Yep, the fifth power. Well done. You're exactly right. So we put it in parentheses and we raise it to the fifth power. Another word for that, if you go on in math, is exponentiate. We raise it to an exponent. Okay. So 0 to the fifth power is 0, 0, 0, 0, 0, 5 times. That's just 0. The fifth root of something raised to the fifth power means you have 5 copies of the fifth root. You have 5 of the kind. So it's gone. It's just x. Well done. So my x-intercept is the origin. But if that's my x-intercept, that's also my y-intercept. Now, how could you prove it if you wanted to? Replace x with 0. So y would equal the fifth root of 0, which is still 0. Okay, so you could prove it both ways if you'd like to be extra careful. But once you have one of them the origin, then the other one's the origin too. Okay. Now, let's talk symmetry. That's definitely the new concept today. Okay. So for symmetry here, remember, we're allowed to kill 2 birds with 1 stone. I like that saying, if you haven't noticed. By simply doing the same thing for both of these, right? So for the first 2, we simply change our signs of our x's. So let's change the signs of our x's and see what happens. Again, to be y-axis, we better get exactly the same thing. To be origin, we better get exactly the opposite. Okay, so when I change the signs of my x's, let's see what happens. This is going to be a little trickier. We would have y equals the fifth root of negative x. Well done. Now, if you're not sure what that means, first of all, some of you might be nervous because you don't like negatives under radicals, okay? But negatives are okay under an odd index. Remember? For example, let me show you my favorite one here. If I had the fifth root of negative 32, that's saying, is there a number that multiplies by itself 5 times to give me negative 32? There is, actually. Do you know what it is?
-2.
Yeah, negative 2. Yeah, good job. So when I put in negative 32, so that's like my x here, okay? I got a negative 2. But what would happen if I did a fifth root of positive 32? It would just be 2. Notice what happened, okay? When my x was positive, I had a positive y. When my x was negative, I got a negative y. So didn't we get the opposite? We did. Opposite is when we have origin typically. Yep. And so basically another way of saying that, you can either show me that you did it with numbers, or you can show me that you know this is always the opposite of the original. Anytime you have a negative under an odd index, you will get the opposite of the original. That's what we just showed with the number here. Okay? So that is the opposite. It's not the same, right? So if it's the opposite, which of these is happening? Origin. If it had been the same, it would have been y-axis, wouldn't it? Okay. Now, again, because this is a function, you're technically done. It won't have x-axis. But if you need to show me, if you don't know it's a function, then you need to actually show me that it doesn't have x-axis. So how do you show that it doesn't have x-axis? instead of changing the signs of the y values, good job, you change the signs of the, sorry, I said x, you change the signs of the y's. I said it wrong, sorry. Okay, so instead of changing the signs of the x, change the signs of the y. But let's see what that would mean. Negative y equals the 5th root of x. The question again is, for x-axis, when you do that, do we get the same thing that we started with? Is that exactly the same thing that we started with? No, here we said y will be whatever the 5th root of x is. Here we're saying the opposite of y will be that. That's different. So this is not the same. So since it's not the same, no x-axis. Okay. But again, if you already knew it was a function, then it's only one of those two. So you can be a little clever going forward. Okay, so this takes some getting used to. We'll do one more. This is much easier than the radical, I promise. Here's c.